So consider sin x as u and cos x as v. So consider u as constant, so sin x will constant, and differentiation of cos x will be minus sin x. Consider cos x as constant, differentiate sin x, it will be cos x. So this will coming to be minus sin square x plus cos square x. Cool. And if you see here that cos x square minus sin x square is basically cos 2x. So this can also be written as this way. Cool. I hope it is clear, right? Very good. So you must be aware of this rule, simple rule. We will deal more question later on. Let's read rule number 3. Rule number 3. Division rule. Division rule. What is this? If y is equals to u by v, and u as a function of x, and v as a function of x, right? And you have been asked differentiate y with respect to x. Rule is first write down v square in the denominator and put v as constant and differentiate u with respect to x. Put a minus sign. Now u as constant, differentiate v with respect to x. This is the formula. Let's say y is equals to tan x. How will you differentiate? You can write down tan x as sin x by cos x, and you have to calculate dy by dx. You can say it is u, you can say it is v. Now apply the formula v, which is cos square x. Now cos x as constant, sin x as cos x, minus then sin x as constant, cos x as sin x is constant, and cos x as minus sin x. And all the way you can see it is cos square x plus sin square x, which is 1 by cos square x, which is going to be sec square x. You can see this, right? I hope you understand. This is how you can apply the division rule. Now next, chain rule. The most important one, a little bit difficult one as compared to the other rules. Try to understand it clearly. How will you get it? Chain rule. So for this one, you have to come back to the formula list and get the realization of the formula. What is in the formula? That whenever you are seeing that you are going to learn this formula, if it is x here in the base, in the denominator, it is going to be differentiated with respect to x. There shouldn't be any change. If there is any change, you can't apply the formula. This is a simple thing which you have to keep in mind. Like if it is x here and it is also x here, no problem. Formula is valid. If it is x square here and it is x here, formula is not valid. Clear? Similarly, if it is x here, it is x here, formula is valid. X valid, x valid, valid all the time, x valid. Fine. So let's try to understand what happened if it is not in that way. As you learn the formula, the question is not in that way. How will you proceed? The rule is called chain rule. Let's start with the question. Y is equals to sin x square. You have been asked get the value of dy by dx. You apply the formula, put y as sin x square, put dx here. Now you have been stuck. What to do again? What to do ahead? Since the formula is not matching, this is x square and this is x. How can you apply the formula? No formula directly. No formula directly. So what you will do, you will have to use a formula in a different with a different approach, so that your formula can be utilized here. Like you have to use differentiation sin x square, differentiation x square, then differentiation with respect to x square, then with respect to x. Can't you see here that if it is x square, it is also x square? The same thing is matching here. I'm repeating, if the things are same, you can apply the formula. If the things are different, you can't apply the formula, right? So if the things are same, you can say sin's differentiation is cos. So your answer for this part will be cos x square. Now what about this? This is in the formula list and this is x square, and the x raised to n formula can be utilized here. So it is 2x. The answer is 2x cos x square. I hope you understand. This is how the chain rule works. This is how the chain rule works. Let's move ahead for the next question. Let's say I'm saying y is equals to 3x plus 5 raised to 100. and you have been asked get dy by dt. Now the thing is, when you are going to approach, you have to write y as 3x plus 5 raised to 100, then with respect to t. But you are seeing that this is x, this is t. How will you do ahead? So again apply with a different approach. So what you will do, whatever it is written here, put here. Differentiation 3x plus 5 raised to 100 with respect to 3x plus 5 multiplied by 3x plus 5 with respect to x multiplied by x dx with differentiation of x with respect to t. Now going ahead, you can see that this is whatever it is written here. Let's say it's a capital X. It is capital X. Now you can apply x raised to n formula. It is what? 100 into x raised to n minus 1, which is 3x plus 5 raised to 99 into this can be, here we can use addition rule. You can separate, and it's a constant, so 3 will be out. X differentiation with respect to x is 1, 5 differentiation with respect to x is 0. Now moving ahead, it is dx by dt. You can't do anything with this, so put it as it is. Okay, so the answer will be 3 into 100 is 300. So it is 300 into 3x plus 5 raised to 99 into dx by dt. This is the answer. You can't have the value of this, so put it as it is. Okay, that's it. This is Chendu. This is how it works. Okay, so your work is to apply the method and to have a good command over it. Okay, clear. Another thing which you can remember is partial differentiation. Another rule. What is this? When you have y and you have x square y z, let's say these three variables are there, all x square y and z are variable, and let's say it is u, not y, and you have been asked differentiate u with respect to x. But the problem is, how will you differentiate u with respect to x only when it contains three variables? It contains three variables and all the variables are different. It is not x. Keep in mind, these are not varying with respect to x. Y is different variable, z is different variable, y is in y axis, z is in z axis, x is in x axis. All the axes are different. So what you have to do in such cases, partial differentiation comes in action, and you have to write down partial differentiation with this way. The d will be like this. Okay, this is du by dx. Okay, du by dx. Whenever you find that it is written like this, this is notation for partial differentiation. So under partial differentiation rule, you have to keep in mind, when I am doing with respect to x, other thing will be treated as constant. Okay, other variable will be treated as constant. Variable even will be treated like constant. Constant will be constant always, no problem at all. No problem with the constant, that will be constant as it is in this case or in the previous cases. But even the variable which is other than x will be considered as constant. Let's say we have to differentiate with respect to x. So x is only variable, y z is constant. Put it y z out of the differentiation box. Put x square in this one with respect to x. So your answer, x square is 2x, so answer is 2xyz. This is how you do partial differentiation. Like another example, let's say u is equals to 2x plus 3yz, and you have been asked to calculate differentiation of y, partial differentiation with respect to y. What you will do? 2x, this whole term becomes constant because you have to do differentiation with respect to y, so this will become 0. 3z will be constant, and y differentiation with respect to y is 1. xy, x is constant and y's differentiation with respect to y is 1. So answer will be 3z plus x. This is how you do partial differentiation. That's it for differentiation. Thank you.